Friends, today we will see composition of function. Composition of two functions in fact. We know that we can combine two functions. We can say suppose we write sine x square. Actually function is sine x. Sine x square means this is composition of sine function and a square function. So this is not new one, only name is new one. In class 10 also you used to write sine x square, tan x square like this. Let us see proper definition of composition of function. Let f from a to b. F is a function from a to b and g is a function from b to c. The composition of function f and g denoted by GOF is defined as a function from a to c by image of x means g of x equal to g of fx for all x of a. Here one point is important. Composition of f and g is denoted by GOF, not FOG. So notation is just opposite. Composition of f and g and notation is GOF. So every element of a is related to some element of C. Some element of C. This property is similar to transitive property of relation. So image of x is suppose y under the function f and image of y under the function g is z. Then image of x under the composition function is equal to z, where z is gy and y is fx. So gy is g of fx. This means composition of a function is single function. This is combination of these two functions and image of every element of A will be in the set C. Let us see one example. Very simple example. Let A equal to set containing 1, 2, 3. B equal to set containing 3, 4, 5. C equal to set containing 5, 6, 7, 8. We are taking example randomly. So let's see, f is a function from a to b and g is a function from b to c, and we define as image of 1 is 3, image of 2 is 4, image of 3 is 5. It may be different, but this is for example. And under the function g, since g is a function from b to c, so every element of b should have image in c. So image of 4 is 7, image of 5 is 8, and image of 3 is 5. Once again, image of 3 is 5, image of 4 is 7, and image of 5 is 8. Then suppose you have to find out GOF. To find out a function GOF means to find out images. So under the composition function GOF, image of 1 is image of 1 under the function f at first. So image of 1 under the function f is 3. So f1 is 3, and finally g3 means image of 3 under the function g is 5. Similarly, image of 2 is at first 4, and image of 4 under the function g is 7. Image of 3 under the composition function is g of f3. f3 is 5 and g5 is 8. In terms of ordered pair, we can write GOF equal to 1, 5, 2, 7, 3, 8. So finally we can conclude that composition of two function f and g denoted by GOF is a function from A to C, and images of elements of A will be in set C. Similarly, we can find out composition of F and G, but composition of G and F and G notations are different. Composition of G and F denoted by FOG. Composition of G and G we can find out. Composition of F and F means composition with same function. These may be defined. Let us see one example. Actually, this question has been asked so many times in board exams. That's why I am taking this example. If f is a function from R to R, real number to real number, set of real number to set of real number, and the rule is fx equal to 3 minus x cube and whole power 1 by 3. Find out f of f, composition of f with itself. So to find out f of f, composition of a function, means to find out images. So let us find out f of fx, image of x under the function f of f, means composition of f with itself. So f of fx means f of fx, and fx means 3 minus x cube power 1 by 3. So let us suppose this one as z. Z means 3 minus x cube and whole power 1 by 3. And fz equal to, again we write x in place of x, z. So fz equal to 3 minus z cube power 1 by 3. And this is equal to 3 minus, let us put the value of z. So z is 3 minus x cube power 1 by 3 and whole power 3, and after that the whole power is 1 by 3. So if we simplify, this will come as x. Since composition of a function with itself is x, and this is nature of identity function also. Image of x is x, image of x is x. This is called identity function. In class 11 we have studied. So here composition f with itself is an identity function also. Then next important concept is invertible function. Let us define invertible function. Let f and g are two functions such that g of f of g both are equal to I. Composition of f and g and g of f both are equal to I, where I stands for identity function. Identity function means image of x equal to x for all x of the domain, means image of 1 is 1, image of 2 is 2, image of 3 is 3, like this. So if composition of two function with commutative property, here this one is also important, f of g equal to g of f, both are equal, means composition of two function hold the property of commutative. So first of all, composition is commutative and both are equal to I, identity function. Then g is called inverse of f and also f is called inverse of g. And we denote inverse of f as f of power minus 1. But minus 1 is not power. It looks like a power. This is symbol of inverse function. So dear students, we may compare this concept to inverse of a number, multiplicative inverse of a number or additive inverse of a number. We know in number theory, suppose inverse of 2 is 1 by 2. This is the inverse concept of multiplicative inverse. Inverse of 2 is 1 by 2 because if we multiply 2 and 1 by 2, it is 1. 1 is called identity. So if we multiply two number and result is identity, then the two numbers are inverse of each other. So this concept is also similar to that one. A function is called invertible. Some important point. First note is a function f is called invertible if and only if it is 1 onto function. So this one is important. If a function is invertible, means invertible function exists only when the function is 1 onto. Why it should be 1 onto? If a function is not 1 then what happens? So two element of domain may have same image. So if we define in function in reverse order, this contradicts the concept of function. So function must be 1. Similarly, if function is not onto function, then some element of codomain may be left out. So if we define a function from opposite side, means B to A, then some element of domain will be left out. This means for defining inverse function, the original function must be 1 onto function. Inverse of a function is denoted by f minus 1. I have already told. Second note is, let y equal to fx be a function from a to b, then obviously f inverse is a function from b to a, and we write f minus 1 y equal to x. That is, image of y under the inverse function is x if and only if image of x under the function f is y. So I think the concept of invertible function is clear, but you have to study these PowerPoints in details along with your books also, NCRT book or N Sharma book. So then, to clear the concept of invertible function, let us see some example as a illustration. First one is, let f is a function from n to y. F is a function from n to y, and rule is fx equal to 4x plus 3. Here, what is y? Y is set of natural number for which y equal to 4x plus 3. Means y is only range of this function under this rule. So we have suppose codomain and range both are same for this function. Let us suppose if this function is invertible, find f inverse. We can prove that this function is invertible, but suppose this function is invertible and just we have to find out f inverse. So here y equal to fx and fx is 4x plus 3. So if we express x in terms of y, we have x equal to y minus 3 divided by 4. This means to find out inverse of a function, we have to express x in terms of y. So f inverse y equal to y minus 3 by 4. But we express a function always in terms of x. So we may write f inverse x equal to x minus 3 by 4. A student, you should not confuse that f inverse x and fx. There is a tradition to write a function always in terms of x. That's why in place of y, we write x. Actually, f inverse y is y minus 3 by 4. This is correct one. But traditionally, we write the function in terms of x. So, we may write the function in this way. Then see one another important question, and this question has been asked so many times in board examination. That's why I am taking these questions. Let f is a function from r plus 2 closed open interval minus 5 to infinity, and rule is fx equal to 9x square plus 6x minus 5. Prove that f is invertible and also find inverse of this function. Here r plus stands for positive real number, and minus 5 infinity means set of all real numbers greater than equal to minus 5. So there are two ways to prove that the function is invertible. First one is we can prove that f is 1 1 on 2, and second one is by using composition theory. If composition of two function is identity, then another one is inverse of first one. But I want to explain the first method. For students, I think this is easy, but in books you may see another method also. So let us see by first method, means we have to show the function is 1 1 on 2. If we are able to show the function is 1 1 on 2 function, then we can say that the function is invertible. For 1 1 on 2, we have to prove function 1 1 as well as on 2. So for 1 1, let us use the theory fx equal to fy implies x equal to y. So as per us rule, fx equal to 9x square plus 6x minus 5, and fy equal to 9y square plus 6y minus 5, just replacing y in the rule. So if we simplify, 9 may be taken as common. So 9x square minus y square. If we shift 9y square in this side, then if we take 6 as common, then 6x minus y minus 5 both sides cancel, and this is equal to 0. If we take common, so in 9 and 6, 3 is common. X square minus y square can be written as x square x minus y into x plus y. So x minus y is also common, and it remains 3 into x plus y plus 2. Since x and y are positive integers, our domain is R plus, set of positive real number, not integer, sorry, real number. So 3x plus 3y plus 2 cannot be 0. This means first factor is 0. So x minus y equal to 0, and this means x equal to y. So the function is 1 1. Then for onto means we have to show that every element of codomain have pre-images in domain. So let y is any arbitrary element of codomain and y is image of x, means y equal to fx equal to 9x square plus 6x minus 5. This is wrong. Type equation here, this is wrong. So y equal to, we can make it perfect square. So this is 3x plus 1 whole square minus 6. And if we find out x in terms of y, so we have x equal to minus 1 plus root over y plus 6 divided by 3. We are taking only positive value because in function we cannot repeat the element, otherwise it will contradict the concept of function. That's why we take only positive sign. So this This is defined only when y plus 6 is positive, that is y greater than minus 6. And here codomain is real number, set of real numbers greater than minus 5. So obviously for every y of codomain minus 5 to infinity, this is defined. This expression is defined. That is, we have x. This means every element y of codomain has its pre-image x in domain. This shows that the function is onto. So the function is 1 1 as well as onto. So we can say that the function is invertible. To find the inverse of a function, let us see this one. Since x equal to minus 1 plus root over y plus 6 by 3, and in place of x we can write f inverse y. So f inverse y equal to minus 1 plus root over y plus 6 by 3. This is the inverse of the function. So we have discussed only two examples, two problems, but both the problems are very important for examination. You have to see some more problems in your book. Actually, for detailed study, you have to go to the book also. Otherwise, you will not have command on this topic. This is just brief discussion of composition function and inverse function. Thank you.